Okay, so this is chapter 5, number 57, and the problem says a crate of weight Fg is pushed by a force P on a horizontal floor. A, if the coefficient of static friction is mu s and P is directed at angle theta below the horizontal, show that the minimum value of P that will move the crate is given by the formula P equals mu sub s Fg times secant theta over 1 minus mu sub s tangent theta. So for this problem, we have to realize that the crate is in equilibrium just before it starts to move. Okay, so the first thing I did is I made a free body diagram to show all the forces acting on it. So we have the normal force acting upwards, which is N. Then we have the sort of horizontal and vertical force, P. Then we have the force of gravity going down, which I labeled Fg. Then we have the frictional force, which is Fs. So first, we're just going to write down our givens, and our given is P equals mu sub s F times G, or F sub G, secant theta over 1 minus mu sub s tangent theta. And then for this problem, you need to first find the vertical and the horizontal component. So first we're going to find the vertical ones. And then the vertical is just, it's going to be your normal force. So your normal force will equal the force of gravity plus P sine theta. And the sine theta is in here, so because it's what accounts for the vertical component of P. And then next we need to find the horizontal, which is going to be P cosine theta is equal to your frictional force. And the cosine theta in this accounts for the horizontal part of the P. So we know that the frictional force has to be less than or equal to mu sub s times n, since the block is moving down the slope. So P, or we could sub in P cosine theta to get P cosine theta is less than or equal to mu sub s times Fg plus P sine theta. And that's just from right here. So once we just kind of rearrange it, it's going to be P parenthesis cosine theta minus mu sub s sine theta is less than or equal to mu sub s times F sub g. And then from here, we divide the cosine, so it's going to be P times 1 minus mu sub s tangent theta is less than or equal to mu sub s Fg secant theta. And then this, after rearranging, gives P minimum equals mu sub s F sub g secant theta over 1 minus mu sub s tangent theta. Part B says to find the minimum value of P that can produce motion when mu sub s equals 0.400 and the force of gravity, or Fg, equals 100 newtons and theta equals 0 degrees, 15 degrees, 30 degrees, 45 degrees, and 60 degrees.
Mature guys.
Okay, so first off, we have to plug all our values into the equation. So it's going to be P equals 0.400 times 100 newtons times secant of theta, and theta will be varying throughout the whole entire problem, is going to be 1 minus 0.400 tangent theta. And then first thing we have to do is we plug in all these values into this equation. So first we're going to plug in 0, and after plugging that into the calculator you should get 40 newtons, 40.0. And then you plug in 15, and then that should give you 46 60.4 newtons. Then 30 degrees should give you 60.1. And 45 should give you 94.3 newtons. And 60 degrees should give you 260 newtons. And then on this problem, you might notice that for an angle that's over 68.2 degrees, there can't be any motion that exists, so it would be impossible for it to go down. This has been Chapter 5, number 57. Thanks for watching.